Welcome to our final project in Neurofuzzy Systems presentation by Elizardo Llanos, Ángel Gustavo, and speaking here, Pablo Dominguez Duran. We are presenting a COVID-19 web app test. Okay, so the problematic many of us will be really familiar with, it's COVID-19 pandemic. At this point in Mexico, we are experimenting and increasing the cases and a lot of population, as we can see in this piece of news that we came up with last week. With Locatel emergency line, it has to stop ringing and having a lot of calls each day about just consulting about the virus and the symptoms, and we made aware that the rest of emergencies in Mexico are still happening. So what is the problem here? A lot of people that may not be familiar with the symptoms is having a lot of doubts and concerns regarding the pandemic and the virus symptoms. So just take a look at the statistics in Mexico just about yesterday, in which we have a cumulative confirmed cases of more than 150,000 confirmed COVID-19 and more than 18,000 deadly cases. So we're in the peak of the pandemic by now, and in the week of June the 17th in 2020. So we wanted to present just a solution, just something that could help some of them with doubts. It is a reliable and free test for COVID-19. It's a web app that is accessible in web browsers, and it works really well on laptops, desktops, mobile phones, and that's why we wanted to be the more accessible out there in as many devices. This is how we present here, just user data and contact form, the symptoms test that we go deeper later, and the result is screen here. Okay, we thought about this as what would be the most correct approach to the web app, and we're thinking about a modern web architecture application in which we're using modern technologies such as React for the front end. The front end is the part that the users are having in their browsers, and the other part that we call the backend is that the one that is stored in computers or servers away from the user, and they're communicated through a RESTful API. So the technology we are seeking to use in the front end is called React.js. It is code in JavaScript, and it's a standard right now in the industry. A lot of companies such as Facebook, Netflix, Instagram, Airbnb, among others, use for their applications. And we could have other cloud technologies such as Google Cloud, AWS, Azure to communicate via a RESTful API to the web application made by us. Here in the let's call it the backend part, we will have our trained model in which would be consumed by the front end to deliver our accurate result for the user symptoms. So this is like the large scale architecture we are presenting, but the actual implementation like we came up with is a little more not that much scalable, but is also really much maintainable. So we are still using the React library to make the UI and the, let's say, the front-end application. And we also using TensorFlow. So TensorFlow is still could be still used in the part of Google Cloud, let's say. It could be consumed there, but right now we are integrating it into the front-end application as is still in JavaScript. This makes us use just not the same characteristics as we would have in the cloud, but is a lot just a bit easier for us at this moment to integrate it within the web app. This would be at the end we would have a larger application that it wouldn't be that much scalable, but right now is just a prototype, and it is stored in the GitHub pages service. Okay, that's about the actual implementation of the application, and here we have our neural network. Okay, here you can see the simplified diagram. Okay, as the input would be the, let's say, the symptoms that the user picked. It would be in total 15 that we will later see in the next slide. And this will enter the first neuron, and it would be processed or into a sigmoid log, actually a logarithmic sigmoid activation function, and this will go to our second layer that has an activation function of purelin, and we're using the back propagation algorithm to compute the results and train the model. Okay, so this is our modeling that we are proposing, where we picked the most 15 common symptoms that the World Health Organization is releasing for COVID-19 patients. So we make a scale of the severity that goes from the worst that we have a number 6 in it, and to the, I wouldn't call it better, but let's call it less worse, that have a scale of 1. So you can see here that the most, let's say, decisive symptoms that make someone be diagnosed by COVID-19 is chest pain, shortness of breath, and fever, and among others that are accompanied by the virus, but are not that as much as decisive to diagnose COVID-19. So these symptoms are the ones that were used to train the model. Okay, here we have like the packages or test cases used for the train of the model. So you can see, for example, chest pain here, and having this is the, let's call it the intensity, the symptom intensity. No, oh no, my God, sorry, no, the dangerosity of it, and this here is intensity for 1 to 5. That this is what the user enter in the test. So with this, let's say with these symptoms, we form the test cases. In total, we have 30, and these 30 test cases help us train the neural network. Here is the how we pack and target the neural network, and this right here is how we train it. You can see it is a simple backpropagation algorithm in which we process the results at the end of each of the first layer into the second, and we here in this part we have the sensitivities, and later we have the back propagation back into the algorithm. Okay, you can also see this. This was, just to mention, this was developed in MATLAB, and later it was translated into JavaScript, as we will see later that we make use of a TensorFlow for mathematical operations with matrix vectors and the log sigmoid activation function with TensorFlow. And here we present the best results that with MATLAB, and these are the values, let's call it the trained values that were that went into the front-end application with TensorFlow and are used to compute the results of the user. Okay, let's see the web app. You can see this here is a live demo. If I click on it, I have it right here open prior, and this is how it looks by now. As you can see, it's a React.js application, and it is deployed in GitHub. Okay, so this is a simple contact form, which is just it is not functioning. At the end, we say that we sent like an email, but we don't actually send an email. But this could be made by some other services, such as Firebase, for example, available in the Google Cloud platform. Okay, so let's just fill it with dumb information. Country, Mexico. Okay, let's continue, and this is like the main test. As you can see, first just let me show you, this is a completely responsive web application in which we think it is accessible through many devices, as this is a browser application. So let's go back here. So here the user have to list their symptoms to see how about the severity. So he can pick a value from 0 to 5, and you can see here we have like a little bug. This is the actual value that is computed, and this slider can sometimes have a bad feedback into the state of the application, so we have to be careful with it. It's a bug that we are still fixing. Okay, so let's say this patient have chest pain of 5, chance of breathing of 4, fever 5, lot of dry cough, tiredness bit, blue lips, recent of the smell, muscle ache, sore throat, a bit of nose congestion, headache, chills, a bit of rash, nausea, vomiting, and diarrhea. And this is computed. Well, first we go to the confirmation window, in which we can see the information that was entered by the user. So we can at the same go back and change some symptoms, and you can see still have some bad feedback. We have to be careful. And let's change it like this, and this will later change into the actual values are computed. So we could check the symptoms or go back and change anything, and we confirm, and we will have our result. And in this case, the neural network tested negative for symptoms, but yeah, we could be we have to probably be the same way precautious about it. Let's just fill it again. Dry cough, it's here and here and here and here and here, sore throat, runny nose, chills, rash, vomiting, diarrhea. There's a bit of diarrhea. Let's make this higher. Yeah, and yeah. And let's, I don't know, this one too. Let's see the result. And again, negative. So we have to be careful, as the other symptoms could have like false positive of, or as well true negative. So you have to be really careful. For example, if we test it like this, I suppose it would be positive with the other symptoms at 0. We just tested positive. Okay. So we give some other information to contact numbers for special help, and also make this declaration that it's not decisive data and should probably go and see a doctor. Okay, and we also give the recommendation to visit the official information sources of the government. So that's about it. That's our project. It was quite a challenging project, as we had to go through a lot of let's say investigation to model the data and use JavaScript, the React web app, and how to be the best user friendly, and of course code all of this by our own. So this is about it, the project. Thank you for seeing.